Welcome to the final exam, question number 48, and it asks, what laboratory compaction test is used to determine a soil's optimum moisture content and density? Let's just do A, B, C, D, and mark off the ones we know are incorrect. Alright, right off the bat, I can take down two, because I know they are not laboratory compaction tests. They may not be compaction tests at all, but the impact hammer test is when you hit it with a hammer and see what it does, to see if you have any voids or whatnot. D is the Kelly ball test. That's when you drop a ball on wet concrete to see what it does. And those are both done in the field. And then, so we're down to Proctor test and cylinder test. The cylinder test, if you remember, is, we showed, I went over it last video, where you take it into the lab and you put your cylinder that you poured on the site. So this is your cylinder right here, and you compact it, and it gets, and once it'll shatter, it'll pop, I guess, let's say that, and this'll kind of flake off. And obviously that's not perfect. It can fail many different ways. It could fail like that for some reason, just shear off the side. But that's kind of what it looks like. It will typically make this type of shape. All right, so that is your cylinder test. So we know that's not right, because that's strength. It doesn't do moisture content and density. So you know what is the Proctor test, just based on reduction. And I will now explain what the Proctor test is. The Proctor test kind of looks like well, you have another cylinder, but it's not the same type of cylinder. Usually this was a plastic cylinder that you poured the concrete in on the site. Then you brought it and you took this plastic off and you put just the concrete cylinder up there. And the Proctor test, it came up by Proctor. What it does measure the moisture content and density of the concrete. Wait, I just said concrete. No, it's soil. So that's how you know the difference is. You're not going to have, well, density. You don't need to find moisture content, and density of concrete is not that important. When I say moisture content and how much water it is, when you see moisture content, usually you don't use that terminology with concrete, although it is important how much water is in the concrete. And a slump test will kind of give you that approximate, more of a qualitative than perfect quantitative. So the Proctor test is soil, and you'll put some soil in there and what they do is they can dry it out or add water to it or do what they need to do to make it a perfect density and moisture content that they know, and then they will hit it with a certain number of blows with a hammer. And this is a hammer. I know it's probably not the best drawing in the world. So, and then they'll see how that soil reacts, and from that they can determine the moisture content. Once again, if you're not sure what it is, look it up on the internet. It'll take 10 seconds. I won't go too much more into explaining. I doubt that you need to remember too much about this. Just remember it's for soils and it's moisture content. Other than that, it's probably not too intuitive how they get that, so that's why I'm not going to explain it. All right, I will see you on question 49.